An exponent tells us how many times we have to multiply the base by itself. For example, 2 to exponent 8 means we have to multiply 2 by itself 8 times. And base to exponent n is called power. And you will often hear b to the power of n or b to exponent n. Let's look at the difference between negative 2 in brackets to exponent 4 and negative 2 without the brackets to exponent 4. If negative 2 is inside the brackets, that means we're multiplying negative 2 by itself 4 times. And we know that negative times negative gives us positive. Negative times negative gives us positive. And of course, positive times positive gives us the positive answer. However, if negative is not inside the brackets, we have only one negative, and this exponent 4 refers only to 2 itself. So it's negative or negative 1 times 2 times 2 times 2 times 2 4 times. And negative times positive times positive times positive times positive gives us negative result. So there are two different answers. If negative 2 is in brackets and the exponent is even, we get a positive answer. If negative is not inside the brackets and the exponent is odd or even, we get a negative answer. Since the exponent in the first case refers to the negative 2 and in the second case refers only to number 2. All right, complete practice 1 and check solutions. And check your answers. 0 powers. Any number to the power of 0 is always 1. So anything to exponent 0 gives us 1. 5 to exponent 0 is 1. If anything is inside the brackets and it's taken to the exponent 0, it gives us 1. Same here. Let's look at example 6. We have x times y squared times z to exponent 0. In this case, only z is taken to exponent 0. So that exponent only applies to z. Anything to exponent 0 is 1. So we end up with x times y squared times 1. Okay, complete practice 2. Now check your answers. Notice the difference between C and E. In C, everything is taken to exponent 0 and gives us 1. In E, the 0 exponent does not apply to negative, so we have negative 1. Next, we're going to multiply powers. A squared times A cubed we can rewrite as A times A times A times A times A. So we multiply A 5 times. This is our answer, A to exponent 5. And that's where the rule keep the base, add the exponents come from. We keep the base A and we add the exponents. 2 plus 3 is 5. Let's check practice 3. 3 squared times 3 cubed. We're going to keep the base, 3, and we add the exponents. 2 plus 3 is 5. Let's try B. We keep the base, negative 2. We add the exponents. 2 plus 3 is 5. If our exponent is an odd number, 1, 3, 5, 7, 9, we know that the answer is negative. So we end up with negative 2 to exponent 5. Let's try F. Here we have two different bases. We have 2 times 2 times 2 times 3 times 3. We can write it as 2 to exponent 3 times 3 to exponent 2. Since the bases are now different, we cannot simplify it anymore. And let's try one more. G, let's keep the base. 10, add the exponents. 5 plus negative 3 is 2. We have 5 positives and 3 negatives. And now complete practice 3. And when you're ready, check your answers. Notice that if the exponent is 1, we don't write it. So x to exponent 1, we keep it as x. 2 to exponent 1, we keep it as 2. So when we multiply powers, we keep the base, we add the exponents. When we divide the powers, we keep the base and we subtract the exponents. A cubed divided by a square can be written as a cubed over a square. And we know that a cubed means a times a times a square is a times a, and a divided by a is just 1. And it is 1 because a divided by a equals a, and we subtract the exponents. 1 minus 1 is a 0, and we know that anything to exponent 0 will give us 1. So when we have a divided by a, x divided by x, or 5 divided by 5, we can cross them out because this gives us 1. Let's do a few examples. 3 to exponent 5 divided by 3 to exponent 3 is keep the base, 3, subtract the exponents, 5 minus 3, 2. In B, we have base, negative 5. 4 minus 1 is 3. Since it's the odd exponent, the answer is negative. And we know that this answer is a negative answer, so we end up with negative 5 to exponent 3. Negative 4 is the base, keep the base. 5 minus 2, 3. Again, odd exponent will give us the negative answer. And one more, 7. 4 minus negative 2. 4 minus negative 2 will become 7 to the exponent 4 plus 2. Remember, negative times negative gives us positive. And the final answer, 7 to exponent 6. Now continue and finish practice 4. And check your answers. Let's look at example C for a minute. What if instead of exponent 5 we had exponent 4? So negative 4 to exponent 4 divide by negative 4 in brackets to exponent 2. We keep our negative 4 as a base. We subtract the exponents. Now, since the exponent is an even number, we know it's negative times negative gives us positive answer. So you would end up with 4 to exponent 2, positive 4 to exponent 2. Now let's look at another example. We have a squared taken to exponent 3. So we have to multiply a squared by itself 3 times. We know that we keep the base, we add the exponents, so 2 plus 2 plus 2 is exponent 6. So this is our final answer. There's also a shortcut we can use when an exponent expression is raised to the power. We simply multiply the exponents. 2 times 3 is 6. However, I would suggest doing this question the longer way for like first few times. All right, so we have 5 squared to exponent 3. That's 5 squared times 5 squared times 5 squared. We keep the base and we add the exponents. 2 plus 2 plus 2 is 6. A cubed, everything squared, means a cubed multiplied by a cubed. Once again, we keep the base, we add the exponents. 3 plus 3 is 6. We could also do it the simpler, the faster way. We keep the base, we multiply the exponents. 2 times 3 is 6. 3 times 2 is also 6. What if we have 3m to the exponent 4 multiplied, to exponent 3? We have to multiply 3m to exponent 4 by itself 3 times. Once more. All right. Now we have 3 times 3 times 3. We can write it as 3 cubed, or we can write it as 27. And then we have m, keep the base, we add the exponents, so 4 plus 4 plus 4 is 12. We can again rewrite 3 cubed as 27, m to exponent 12. If we do it the other way, we see that 3 has exponent 1. 1 times 3 is 3. And m has exponent 4. 4 times 3 is 12. And in D, we multiply 3m squared by itself. So we get 3m squared times 3m squared. 3 times 3 is 9. M squared times m squared. Keep the base, add the exponents. Again, we can do it the other way. Remember, there's 3 to exponent 1. So 3, 1 times 2 is 2. And m, 2 times 2 is 4. And we get the same answer. So now you know how to deal with the exponents when they have the same basis. What if the base is not the same? Here we have 2 to exponent 5, and here we have 8 to exponent 1. But we know that we can rewrite 8 as 2 times 2 times 2, which is 2 to exponent 3. Now we have the same base. And we know that 4 is 2 squared. Then we can replace 4 with 2 squared. When we have the same basis, we can use the rules that we learned. Keep the base and add the exponents when we're multiplying powers. We multiply the exponents, so 8 times 6 and 2 times 3 times 5 when we're taking power of the exponent. And finally, we subtract exponents when we're dividing the powers. So let's try these challenge questions. 2 to exponent 8 times 2 to exponent 5. It's multiplication, so we keep the base, we add the exponents. Divide by. Now we have to rewrite 16 as 2 to exponent, and we know that 2 times 2 times 2 times 2 4 times gives us 16. So this is 2 to exponent 4 times 2 to exponent 8. And we follow the same rules. We rewrite 2 to exponent 13, and we add these exponents here. So keep the base, add the exponents. Last step is dividing powers. We keep the base, since the bases now are the same. We subtract the exponents. 13 minus 12 is 1. 2 is our final answer. And try the other challenge question by yourself first. And let's see how to do this. So here is multiplying powers, same base, keep the base, add the exponents. We want to rewrite 81 as power with base 3. So 3 times 3 is 9, and 3 times 3 is 9, and 9 times 1 is 81. 9 times 9 is 81. So we have to multiply 3 by itself 4 times. Now, in the denominator, this is division, so we keep the base, we subtract the exponents, and another bracket, we keep the base, we subtract the exponents. Now we have 3, 10 minus 4 is 6, and 3 plus 1 is 4. Final step, keep the base, subtract the exponents. Final answer is 9. And now you're ready for negative exponents. So this is probably something you haven't seen before. So how do we get negative exponents? Look at example 8. We have 3 to exponent 7 divided by 3 to exponent 9. We can rewrite it as repeated multiplication, and we can reduce it. Cancel 3 divided by 3 is just 1. And when we complete it, we see that on the top we have 1, on the bottom we have 3 times 3. And we can rewrite it as 1 over 9, or we can rewrite it as 1 over 3 squared. But when we use our rule, same base, keep the base, subtract the exponents, we get 7 minus 9, which gives us 3 to exponent negative 2. And we can see that 3 to exponent negative 2 is the same as 1 over 3 squared, because that's what we got from here. And you will usually be asked to rewrite the final answer as a positive exponent. So you know that this is 3 to negative 2. However, you should write it as 1 over 3 squared or 1 over 9. Let's try practice 6. So we have 5 times 5 over 5 times 5 times 5. We multiply 5 times by itself. We reduce it. We end up with 1 over 5 cubed. And we know that 5 times 5 is 25 times 5 is 125. So that's 1 over 125. So we have to find the final answer. We have to evaluate it. We could also apply the other rule. Keep the base, subtract the exponents. 3 minus 7 is negative 4. We need to evaluate it. So we know that that's 1 over 2 to positive exponent 4. And that's equals to 1 over 2 times 2 is 4. 2 times 2 is 4. 4 times 4, 16. 1 over 16. And here's the rule that we just learned. A base to negative exponent equals, we take the reciprocal of the base. So reciprocal of 2 is 1 over 2. Reciprocal of x is 1 over x. So we take reciprocal of the base, and then the negative exponent becomes positive. So here 2 to negative 3 will become 1 over 2, take reciprocal of a base, and the negative 3 becomes positive 3, which is 1 over 8. So let's rewrite each power with a negative exponent as equivalent power with a positive exponent. So this becomes 1 over 2 to positive 5. Now pause the video and complete the practice. Check your answers. And here's another example. So if we have a negative exponent, we take a reciprocal of the base. So numerator becomes denominator and vice versa. So we flip it. 3 over 4 becomes 4 over 3, and our exponent now is positive 2. And now we have, since 4 over 3 is in brackets, this exponent 2 applies to 4 and to 3. So we have to square 4 and we have to square 3. So that's 16 over 9. Now complete practice 8 and check your answers. Now let's look at powers of 10. We know that anything to exponent 0 is 1, so 10 to exponent 0 is 1. 10 to exponent 1 is just 10. 10 to exponent 2, 100. 10 to exponent 3, 1000, and so on. So when we're multiplying with powers of 10, for example, 9 times 10 to exponent 2, we know that 10 to exponent 2 is simply 100. So there is a point. Sometimes we write it as 9.0, but we can just write it as 9. There is an invisible point here. And when we multiply it by 10 squared or 100, we move this point 2 places to the right. So the number becomes greater, larger. Let's look at practice 9. 4.29 times 10 to exponent 3. We know that's 1000. So we move this point 3 times to the right. So 4, 1, 2, and 3, 2, 9, and 1 more, that's 0. So it becomes 4290. If it's 2.0 times 10 to exponent 0, we know that 10 to exponent 0 is 1. Anything times 1 stays the same, so that's 2. And then 9.0 times 10, we move the point 1 place to the right, so we get 90. And here, times 100, we move this point 2 places to the right, so we get 536. And in practice 10, we're multiplying powers with the same base. Keep the base, add the exponents. 2 plus -3 plus 1 is 0. And anything to exponent 0 is simply 1. Try the next one. Next, we're going to be dividing with powers of 10. So 9 divided by 100. We have to move the point now 2 places to the left. So we end up with 0.09. So here, 9.0 divided by 1000. We have to move this point 3 places to the left. 1, 2, 3. We put our point here, and we have 0.0090. And try the next one. So once again, 10 to exponent 0 is just 1, but 10 to exponent of -1 is 1 over 10, which is 0.1. 1 divided by 10, 0.1. 10 to -2 is 1 over 10 to exponent 2, which is 1 divided by 100. And 1 divided by 100 is 0.01. And so on. This is 1 divided by 1000, 1 divided by 1,000,000, and so on. Now complete practice 12 and check your answers. So we rewrite each exponent as positive exponent. Now, scientific notation is very important in science because in science we use very tiny things like atoms and viruses and very huge things like in astronomy and physics. And if we write a very small number like 0.00000000002, it is very easy to make a mistake. because there are so many zeros. Or if we write a huge number, then it's again very, very easy to make a mistake. So instead of those standard notations, we use a scientific notation. And to change from a standard notation, like here we have 15 million, to scientific notation, we start with putting a point after the first digit other than 0. So we cannot put it anywhere but after first digit other than 0. So 1.5. And then we count how many spaces are between this point and remember there's invisible point here because it's 15 million. So we had to move 1, 2, 3, 4, 5, 6, 7 spots. That's why that's exponent 7. Now, how do we know if this exponent is positive or it is negative? There are two ways. One is which way we're moving. But for me, it's a bit confusing. Am I moving left or right? The easier way for me is, okay, is this original number greater than 1 or less than 1? If this number is greater than 1, our exponent is positive because we have a large number. If the number, like in here, it's less than 1, we know that our exponent will be negative. And once again, we place the point after the first digit other than 0. So we have to go after 3. 3, we don't have to put 3.0. We just put 3, but we go up to here. And then we had to move 1, 2, 3, 4, 5, 6 spots. So that's times 10 to exponent negative 6. And again, it's negative 6 because the original number is less than 1. So here we have a very large number. This is the speed of light, 300 million meters per second. And if we want to write it as a scientific notation, we put the point after 3. So 3 times 10, and we have to find the exponent. So we moved the point from here to here after 3. That's 1, 2, 3, 4, 5, 6, 7, 8 spots. Since the original number is greater than 1, it's positive 8. So the speed of light is 3 times 10 to exponent 8 meters per second. What about this number here? It's a very small number. We have to move this point to this place after 1. So we put 1.2 times 10. Our original number is less than 1, so it's a negative exponent. And we count how many spots, how many places we moved from here to here. That's 3, 6, 9, 10. So 1.2 times 10 to negative 10. And now pause the video and complete practice 13. And now check your answers. 2 times 10 to negative 6 meters represents the size of the virus. So it's a very, very small size. And now you also need to know how to convert from scientific notation to a standard form. All right, so we have 2.4 times 10 to exponent 6. This is a positive exponent, so we know this number is a large number. It's definitely more than 1. So we know that we have to move 6 places to the right. So we're basically multiplying 2.4 by 1 million, 10 to the exponent 6. So we move the point 4 spaces to the right because it's a very large number, and we end up with 2,400,000. In this example, we have a very small number because it's a negative exponent. So we have to move this point to the left, and we divide by 10 to negative 5. Sorry, we multiply by 10 to negative 5. And remember that times 10 to negative 5 is the same as 1 over 10 to positive 5. So we have to move this point 5 places to the left. And when we move it 5 places to the left, we get 0.000032. So let's do a couple of examples. In A, we have to move this point 7 spots to the right to make it a big number. So 3, 1, 2, 3, 4, 5, 6, 7. And we get 32 million. So here we get a huge number, 32 million. And let's look at E. Since this is a negative exponent, we're going to move this point 10 places to the left. And we get this very small number. Notice that if we move the point 10 places to the left, we end up with 9 zeros. And if it's moved 7 places to the left, you end up with 6 zeros because we're moving 7 places. So we're moving in front of 2 plus 6 more places, 2, 5, and so on. Now complete practice 14 and check your answers. And now check your answers.